an exciting journey through the cosmos to explore one of the most intriguing concepts in modern physics and popular science fiction, wormholes. Are they grounded in science, or are they merely the product of creative imagination? To answer this, we must first understand what wormholes are, the science behind them, and how they are portrayed in science fiction. What are wormholes? Imagine the universe as a vast fabric, stretched out in 3 dimensions. Now picture folding that fabric so 2 distant points touch. A wormhole, theoretically, is the shortcut connecting those points. In essence, it's a tunnel through space-time, allowing for faster-than-light travel between distant regions of the universe, or even between different universes. This idea stems from Albert Einstein's general theory of relativity. In 1935, Einstein and physicist Nathan Rosen proposed what we now call Einstein-Rosen bridges. These bridges, or wormholes, arise as a solution to Einstein's equations and describe pathways through space-time. However, their existence remains purely theoretical, as we have yet to observe or create one. Wormholes are fascinating because they bridge the realms of possibility and improbability. The mathematics suggests they could exist, but there are significant challenges that make them feel more like science fiction than science fact. First, wormholes would likely require exotic matter to remain stable. Exotic matter isn't your everyday material. It's a hypothetical substance with negative energy density. This negative energy could, in theory, counteract the wormhole's natural tendency to collapse under its own gravity. But as of now, we've only observed tiny amounts of negative energy in quantum phenomena, such as the Casimir effect. And scaling this up to stabilize a wormhole is beyond our current technological reach.
Even if we could stabilize a wormhole, it might not be traversable. Some solutions to Einstein's equations suggest that any attempt to pass through a wormhole could cause it to collapse instantly. And there's the problem of immense gravitational forces at the wormhole's entrance, which could easily destroy anything trying to cross it. Finally, there's the question of causality. Wormholes theoretically allow for time travel, which leads to paradoxes like the infamous grandfather paradox. If you traveled back in time and prevented your own existence, how would the timeline resolve itself? These paradoxes remain unresolved in physics, casting doubt on the feasibility of wormholes as practical tools for exploration. While the scientific challenges are daunting, wormholes have become a staple of science fiction, providing storytellers with a convenient way to explore vast cosmic distances without violating the speed of light. In Star Trek Deep Space Nine, the Bajoran wormhole connects the Alpha and Gamma quadrants, allowing for instantaneous travel across 70,000 light-years. Here, wormholes are depicted as stable and navigable, an idealized version that serves the narrative's needs. Christopher Nolan's Interstellar offers a more grounded portrayal. The movie depicts a wormhole as a spherical gateway created by advanced beings near Saturn. The film's depiction aligns closely with theoretical physics, thanks to the input of physicist Kip Thorne, who ensured the visual representation was as scientifically accurate as possible. Then there's Stargate, where wormholes serve as a gateway to other planets. While highly fictionalized, the series captures the essence of what wormholes represent: infinite possibilities for exploration and connection. So are wormholes science or science fiction? The answer is both. Wormholes are firmly rooted in the equations of general relativity, making them scientifically plausible. However, the practical challenges, stabilizing them, traversing them, and avoiding causality violations, place them beyond our current scientific capabilities. Yet science fiction plays an important role here. It inspires curiosity and innovation, pushing us to explore concepts that may seem impossible today, but could become realities tomorrow. Just as the communicator from Star Trek inspired the invention of mobile phones, who's to say that fictional depictions of wormholes won't inspire breakthroughs in theoretical physics or quantum engineering? The future of wormhole research. Looking ahead, the study of quantum gravity, the attempt to unify general relativity with quantum mechanics, may hold the key to understanding wormholes. Theoretical developments in this field could help us better grasp the nature of space-time and its potential shortcuts. Moreover, advances in technology such as particle accelerators and quantum experiments may one day allow us to test the exotic phenomena needed to stabilize wormholes. Though we are far from this reality, the pursuit of such knowledge is what drives science forward. In conclusion, wormholes occupy a fascinating space between science and science fiction. While their existence and utility remain theoretical, they serve as a powerful symbol of human curiosity and imagination. They remind us that the universe is vast and mysterious, and that the line between what is possible and what is imaginary is often thinner than we think. So, the next time you see a wormhole on screen or read about one in a book, remember, while it might be fiction today, tomorrow it could be. Some holes feel like cosmic shortcuts. The Alcubierre Warp Drive is another way to cheat the laws of physics and achieve faster-than-light travel. It was proposed in 1994 by physicist Miguel Alcubierre, who was inspired by science fiction, especially Star Trek. At first glance, it seems impossible to travel faster than light. Einstein's theory of relativity tells us that as an object approaches the speed of light, its mass increases, requiring infinite energy to keep accelerating. But Alcubierre had a brilliant idea. Instead of moving through space, why not move space itself? How it works, imagine you're standing on a rubber sheet, representing space-time. Instead of walking across it to reach your destination, what if you could stretch and squeeze the sheet so that your destination comes to you? That's the basic idea of the Alcubierre Warp Drive. Here's how it works. 1. A spaceship sits inside a warp bubble. 2. The bubble compresses space-time in front of the ship and expands space-time behind it. 3. The ship itself doesn't move faster than light within the bubble. It's space-time around the bubble that's doing the moving. This clever idea doesn't break the laws of relativity because the ship isn't technically traveling faster than light. It's space-time that's bending. Challenges of the Alcubierre Warp Drive. Just like wormholes, the Alcubierre Warp Drive faces some enormous hurdles. 1. Energy requirements. The amount of energy required to create a warp bubble is astronomical. Early calculations suggested it would need more energy than the mass of the universe. Later estimates reduced this number, but we're still far from having the technology to generate that kind of power. 2. Exotic matter. Like wormholes, the warp drive relies on exotic matter with negative energy to create and sustain the warp bubble. While tiny amounts of negative energy have been observed in quantum physics, producing it in large, usable quantities remains science fiction. 3. Stability and control. Even if we had enough energy and exotic matter, controlling a warp bubble would be another challenge. Any slight instability could cause the bubble to collapse or behave unpredictably. 4. Radiation risks. Some theories suggest that the movement of a warp bubble could create intense radiation that might destroy the ship or anything in its path. For now, both wormholes and the Alcubierre Warp Drive remain in the realm of theory. The study of quantum mechanics, space-time, and energy continues to reveal new possibilities. But science is always advancing. One day, technologies we can't yet imagine may unlock the secrets of exotic matter or allow us to harness the immense energy needed for these concepts. If that happens, humanity might finally become an interstellar species, exploring the stars and discovering new worlds.